Okay, welcome to the short run video part 2. This video is going to focus more on the homework than the notes. So on number 2, they are telling me that the long run behavior of this graph is going to look like a -3 over x, which means it's going to have a horizontal asymptote at y equals 0. And because it's a -3, it's going to be below on the right and above on the left. So that's the first thing I can figure out just by looking at the long run behavior. When they give me my short run behavior, they're telling me more about what's happening on vertically. So vertically, it says it's going to look like a -3 over 2 x minus 2. So that means I'm going to have an asymptote at x equals 2. So I go right here to x equals 2. And because it's going to behave like a -3 over 2, that means it's going to go down on the right and up on the left. So it's going to go down over here, but it's going to go up over here because of the negative. The second one says that I'm going to have a vertical asymptote at x equals -2. So I come over here to -2. And again, it's a negative. So once again, I'm going to go, because it's a -2, I'm going to go down on the right, and I'm going to go up on the left. So if I were to sketch this, it would look something like this. And then in here, it's going to have this little curve point. I don't know exactly where it's going to curve at. I'm just making a guess. So now I'm going to go look at my different options here of what it could be. So this first option, it's got an asymptote at +2 and -2, just like I did, but it's a positive up here. So A is not going to work because I need it to be a negative. On this one, I've got a negative up here just like I wanted, so that part's good, but it only has a +2, so that's not going to work. I need a +2 and a -2. This has a +2 and a -2. This has a +2 and a -2. But C has a horizontal asymptote at at -3, and we have one at 0. So my answer is D. Okay, so that's how you do number 2. Let's go take a peek at number 3. That was another one you were supposed to do tonight. This one's a little bit harder. So it tells you it's going to look like the parent 1 over x, but then it puts this little kicker in here. It says your horizontal asymptote is going to be y over x minus 2. Okay, so that means I'm going to have a dot at -2. And I'm sorry, it's not horizontal, it's oblique. And I'm going to have an oblique asymptote at the line x minus 2. But they tell me it's going to behave like 1 over x. So it means it's going to be up on the right, down on the left. Over here on the short run, they tell me that I'm going to have a vertical asymptote at -2. And they tell me that it's going to behave like 1 over x, a positive 1 over x. So it's going to go up on the right, down on the left. So I know it's going to look something like this. And they also tell me that it's going to have a hole at 1. Okay, the reason the hole at 1 is important, because that means somewhere in my equation, I'm going to have an x minus 1 over an x minus 1. So that's what I'm looking for. Well, this one has an x minus 1 over x minus 1, and it also has a vertical asymptote at -2, but it doesn't have a horizontal asymptote that's oblique. This one, the horizontal asymptote would be y equals 0, so that's not it. On this one, nothing cancels. There's no x minus 1, so it can't be that one. This one has an x minus 1 and an x minus 1. If I were to go look at what's left, this would give me a -2, and if I were to go divide, because it's bigger on top than it is on bottom, I would get something oblique. So C, that's a possibility. This has an x minus 1 and an x minus 1, which would give me the whole. On the bottom, this +2 would give me x equals -2, so that works, and it's bigger on top than it is on bottom. So I'm going to say that both of these are actual possibilities. Since I don't know exactly where the whole is, the exact y value, either one of these could give me something that looks like this. Okay. The next one I asked you to do, if I didn't have time to do it in class, was number 6. There were a few classes that I got to do this one, so if I did this one with you, just fast forward the video. All right, so on number 6, in order to figure out what it's going to look like on this particular problem, I have to go reduce my leading coefficients. But when I go reduce, I end up finding out that it's bigger on top than it is on the bottom, so we have to divide. So how many times will 1x go into x squared? It goes x times x is x squared, x times 1 is minus x. And then we subtract, and when I subtract, I end up getting a positive x. Well, that means I can keep dividing. How many times will x go into x? It goes plus 1 times, plus 1 times x is x, 1 times negative 1 is negative 1, and then I have to subtract. So my remainder ends up being a minus 1, which is a plus. Okay, so after doing all this division, we find out that we have y equals 1 over x minus 1 plus, and I have what's on top, x plus 1. Okay, here's what that means. It means it's going to look like a 1 over x, so that's what it's going to look like. But it's going to have an oblique asymptote at y equals x plus 1. So I'm going to go graph the line x plus 1. And because it's going to look like a positive 1 over x, it's going to be up on the right and down on the left. So up on the right and down on the left. So your behavior statement would say, as x approaches infinity, my graph is going to be above x plus 1. And as x approaches negative infinity, my graph is going to be below x plus 1. So that's the long run. Now I'm going to go focus on the short run behavior. So on your short run behavior, it looks like we're only going to have one asymptote. So there's only one binomial under here. So I have x minus 1, so it would be 0 when x equals 1. So my vertical asymptote is x equals 1. Okay, and then I have to take the 1 and I have to plug it in everywhere there's an x except in this spot. So if I plug it in up top, I get 1 squared over x minus 1. That means it's going to go up on the right, down on the left, because it's a positive here. So I'm going to go up on the right of this line and down on the left of this line. So our behavior is going to say, as x approaches positive 1 from the right, my graph goes up to positive infinity. As x approaches positive 1 from the left, my graph goes down to negative infinity. And we decided that we weren't going to do any test points, but we do want to know our x and y intercepts because that'll give me a better picture of my graph. So to find an x-intercept, let's do the y first, I'm sorry. To find the y-intercept, we're going to remember to let x equal 0. So I'm going to use my equation up here. Y equals 0 over squared over 0 minus 1. So 0 over negative 1 equals 0. So it's going to have a y-intercept at 0, 0. Well, hey, that's not just the y-intercept. That's also the x-intercept. So we're actually done. So now I'm going to go sketch in what this would look like. Now remember, this little piece, I don't really have any of my little bitty test points, so that's as close as I'm going to get. Okay, number 6 is done. All right, let's go take a look at number 7, and then we'll do number 9, and then we'll say we're done for the night. Okay, so on number 7, this is a nice one as far as long run behavior goes. We're going to look at our leading coefficients, and I have 5x over x squared. So 5x over x squared, we're reduced to 5 over x, which means it's going to look like a 1 over x. And because I didn't have to do any dividing, I'm going to have a horizontal asymptote at y equals 0. Okay, you're only going to have an oblique asymptote or something that's not 0 if you have to divide. If it reduces right away, then it's going to be at the y equals 0 line. Okay, now, it's a positive 1 over x, so it's going to go up on the right and down on the left. So I'm going to go write my behavior statement. I'm going to say, as x goes off to infinity, my graph is going to be above the 0 line. And as x goes off to negative infinity, my graph is going to be below the 0. Okay. Now we're going to come over here and do my short run behavior. To do the short run behavior, we have to go factor this. So I'm going to do this right, I'll do it right over here. So we're going to have, I lied, I'm going to do it right here. Y equals 5x over, I'm looking what factors of negative 6 add up to positive 1. So that's x plus 3 and x minus 2. So now that I know what my factors are, I can do my vertical asymptotes. So this first one right here, I've got x plus 3, which means x equals negative 3 is going to be one of my vertical asymptotes. So I'm going to come over here to negative 3, and I'm going to draw my vertical line in right here. And before I can draw my arrows, I have to figure out how it's going to behave. So right here it says looks like. To figure out the behavior, I have to come up here to this equation, and I have to go plug this negative 3 in right here and right there. So if I plug a negative 3 in on top, I get negative 15 over negative 5. Well, a negative 15 over a negative 5 is going to give me a positive 3. Okay? So it's going to look like a positive 3 over an x plus 3. That means it's going to go up on the right of the line, and it's going to go down on the left of the line. You take that number, let me say it again, you take this negative 3, and I plug it in here to this x and to this x. 5 times negative 3 is negative 15. Negative 3. Negative 3 minus 2 is negative 5. Negative 15 divided by negative 5 gives me positive 3, and the x plus 3 comes down. Because the positive on top, I went up on the right, and I went down on the left. So the behavior statement would be, that's right there. Behavior statement would be, as x approaches negative 3 from the right, my graph goes up to infinity. And as x approaches negative 3 from the left, my graph goes down, which is negative infinity. Okay, now we're going to go do the other asymptote. So my other asymptote would occur right here with the x minus 2. So it would be x equals positive 2. I'm going to come over here to positive 2 and draw that one. And I have to figure out what it's going to look like. So again, I'm going to go plug it into this equation up here. But I'm going to plug the 2 in here and here. Remember, the x minus 2 we leave alone. So I plug in a 2 up here. 5 times 2 is 10. 2 plus 3 is 5. So 10 divided by 5 is going to be 2 over x minus 2. So it's going to look like a positive again. So it's going to go up on the right, down on the left. So as x approaches 2 from the right, the function goes up. As x approaches 2 from the left, the function goes down. Okay. So all I need to do now is figure out an x and a y intercept, and then we can say this one's done. Alright, so to do the y intercept, because that's the one I like to do first, I'm going to go over here to my original equation, and I'm going to plug a 0 in everywhere there's an x. So 5 times 0 is 0. 0 squared is 0. Plus 0 is 0. Minus 6 is negative 6. So my y-intercept is 0, 0. And we also know that's going to be my x-intercept. And because there's an asymptote here, it's actually going to be kind of like a hole, I guess. So we got this side, and then we got this, it's going to kind of curve. It's going to come to the 0 and then come back down. All right, here's number 7. All right, we did number 8 in class, so the last one we're going to look at is number 9. So on number 9, to do the long run behavior, I have to FOIL out the bottom. So on the top, we've got x minus 3, and on the bottom, if I were to go FOIL this, I'd actually FOIL it with negative x plus 4 times x plus 2. So if I do it that way, I can see that a negative x times a positive x is going to give me an x squared. I really just need the first 2 terms. I don't really have to go first term on top and the first term on bottom. So I really can stop right there. Oh, that's a negative, sorry. A negative x times x. So x over negative x squared is going to look like a negative 1 over x, which means it's going to have a horizontal asymptote at y equals 0. We'll go ahead and sketch that in. It's going to be below on the right because it's negative, and above on the left. My behavior statement is going to say, as x goes off to the right to positive infinity, my graph lies below the 0. And as x goes off to negative infinity to the left, my graph is going to be above the 0. Okay, so that's the long run behavior. Again, that's what we did on Tuesday, so that should be getting a lot easier now. Now we're going to go focus on the short run. Our short run's a little bit different. I'm going to have 2 asymptotes. I'm going to have one at negative 2, so I'm going to start with that. Remember what we said, to figure out what it behaves like, I have to come up here and I have to plug this negative 2 in to the x on top and this one on the bottom. Okay, so we're going to have y equals, if I plug the negative 2 in on top, I get negative 2 minus 3 over, x plus 2 comes down, and then I've got a negative, I'm using this one right here. A negative 2 is 2 plus 4. Okay, so on the top, I have negative 2 minus 3 is negative 5. And on the bottom, I have 2 plus 4 is 6. So it's going to look like a negative 5 over 6 x plus 2. The important part is the negative part. It's going to be a negative. And because it's going to be a negative, we're going to go to where x equals negative 2. And because it's negative, on the right side, I'm going to have an arrow going down. And on the left side, I'm going to have an arrow going up. So our behavior statement will say, as x approaches negative 2 from the right, my graph went down. And as x approaches negative 2 from the left, my graph went up. Okay, so that's our first vertical asymptote. The second vertical asymptote is going to be with this one right here. So what would make this a 0? Well, this would be 0 if x equaled positive 4. So 1, 2, 3, 4. Okay. And again, I have to go take 4 and I have to plug it in up top and right here. But I have to leave this piece just like it is. So here's my second one. Y equals 4 minus 3 on top. On the bottom, I'm going to have 4 plus 2, but then I have that negative x plus 4. So on the top, I've got 1 over 6, but because of this negative, it's going to look like a negative 1 over 6 x plus 4. Okay, so because of that negative, I'm going to have to go down on the right and up on the left. So far I know it looks kind of like this. It's not perfect, but it looks something like that. So as x approaches 4 from the right, we're going to go down. And as x approaches 4 from the left, we're going to go up. Okay, so the last thing we have to do is do the x and y intercepts, and then we are done. So remember, I like to do my y-intercepts first. So I'm going to my original equation up here. And everywhere I see an x, I'm going to put a 0. So 0 minus 3 over 0 plus 2, 4 minus 0. 0 minus 3 is negative 3. 0 plus 2 is 2. 4 minus 0 is 0. So 2 times 4 is 8. So I'm going to have a y-intercept. That's kind of weird. At 0, negative 3, 8. Well, look at where I touched. I touched down here somewhere, so that kind of makes sense. Okay, now I'm going to do the x-intercept. I don't have to solve for these very often, but in this case I'm going to have to, so it's going to take a little bit. So to get my x-intercept, I'm looking at this graph, and hey, what do I notice? We notice that the x-intercept does not exist because there's a horizontal asymptote right there. So even though it looks like it crosses, there's going to kind of be a little bitty hole right there. All right, that's it. Hopefully you got something out of this. Hopefully all your homework's done. Good job.